This is video 825, and the goal here is to continue writing parabolic rules with some special circumstances here. So we're going to continue to look at graphs and tables in order to write parabolic rules. Let's take a look at this first example. We always want to start with writing it as a product, because when we have a product form, we can see the zeros. So we look for the intercepts. Now remember, we're looking for the x-intercepts, not the y. And so we use our intercepts to figure out what our factors should be. Our factors always start with x, and they're plus or minus something. In this case, they'll be minus 1, because when I plug in 1, I should get 0, and I do get 0. The other one is x minus 3, because when I plug in 3, I should get 0, and it looks like I will get 0 if I plug in 3 right here. So I have my two intercepts, and I have my factored form. Now I want to check it with a point, and I usually like to check it with a point like the other intercept, the y-intercept. So now I'm going to plug in negative 0 and check and see if I get negative 3. So 0 minus 1, 0 minus 3. I get negative 1 times negative 3, which is actually 3. So I don't get negative 3. So there's one thing that we're missing, and what we're missing is the a value. An a value is a number, a single number. It doesn't involve x. It's a number in front of the factored form that stretches the graph, that makes it taller or shorter. Okay? It'll make it either grow really fast or it'll make it grow a lot slower. It also flips the graph. If the graph is upside down, that means my a value is negative. So I need to figure out what the a value has to be. Now remember, the a value does not affect the intercepts. Your intercepts will still happen at the same spot, because any number, which is what a is, represents a number, times 0, which is what these will be when they're intercepts, will still be 0. So it doesn't affect your intercepts. But what it does affect is things like your y-intercept or your other values in your table. So we have to figure out what a is. So this actually gives me 3a, because 3 times a. And I want that answer to give me not just 3, but negative 3. I want it to be negative 3 in order for it to work with my table. So now I look, and I divide both sides by 3, and I see that a has to be negative 1. So whenever your rule does not work for your points, you have to figure out what the a value is. So let's look at that in the next example. Let's finish up this one. So the rule is not just my factors that we saw here, but actually negative 1 in front. Negative 1 times my factors. And that is the rule for this table. I should check it with one more point just to be positive. So I'm going to plug in one more and make sure that it works. I'm going to plug in maybe 2. Let's plug in 2, 1. So if I plug in 2, I should get 1. I want to include my a value, so negative 1 up front. And it looks like negative 1 times 1 times negative 1. Negative 1 times 1 is negative 1 times negative 1 is 1. So it looks like my rule does work, because it works for the fourth point, 2, 1. So this is my rule for this table. Let's take a look at another example with the graph. And let's walk through the process involving a. So now we're going to write a rule to match this graph. So we always start with our intercepts. But now what we want to start with is make sure that we know what the a value is. We might have a number out in front. So let's see, our intercepts are at 1 and 2. So that means my factors will be x minus 1 and x minus 2, because that would make them 0. Now I plug in one more point, and it looks like I'm still going to plug in my y-intercept, because I can tell that it goes through at 4. So that means when I plug in 0, I should get 4. So let's see. When I plug in 0, so 0 for x, I don't know what a is. Maybe a is nothing. Maybe it's just 1. I should get 4. So I'm going to figure out what a has to be so I can get 4. So 4 equals a times negative 1 times negative 2. Well, I can do negative 1 times negative 2. That's just 2. And then a, 2 times a. So it looks like a has to be 2, because if I divide both sides by 2, a has to be 2. So this is just like writing rules for lines. Remember, we're plugging in what we know and figuring out what we don't know. And we didn't know if there was an a value. It looks like my a value has to be 2 in order for this graph to work. So I'm going to put the number 2 right there. So that is my rule. 2 times x minus 1 times x minus 2. I could check it with another point, for instance 3, 4, to see if that works as well. If I plug in 3, I should get 4. Let's just double check that to make sure it works. Let's be thorough. We have y equals 2 times 3 minus 1, 3 minus 2. Looks like we get 2 times 2 times 1. And in fact, we get 4. So when I plugged in 3, I got an answer of 4. So this final point that we saw here did in fact work. So this is my rule. And if you leave it in factor 4, that should be fine. You'll want to ask your teacher if they need a different form. But that is the rule for this particular graph. So remember a couple of different things, very simple steps. Intercepts, then check for a values. So your rule now looks like this. Y equals a times x, x. And you have to figure out what these 3 numbers are using at least 3 different points in your table or your graph. So give those a shot on your next example. Keep looking for those 3 values in order to find your